So good morning everybody and welcome to this basics of lean manufacturing session. My name is Anant and I am going to be the trainer for this particular session. And why this particular webinar is very important. If you are an engineering student or a fresh engineer, you will learn about lean manufacturing and you will be able to get a job. You will become more employable, right? People are now talking about employability skills in India. So you will become more employable and now there is a huge recession due to this COVID. A lot of people are laid off, and there are a lot of people who just came out of the college. So there is a huge, I would say, unemployment situation in India, and this is the time for you to upgrade, right? Because you should not be like the same as your competition. So what is the edge you are having? So lean manufacturing training will give you that edge where you can directly look at a job in the manufacturing sector, because almost all the companies are now focusing on cost reduction, improvement in productivity, because that's how they can also survive, right? So they are looking for continuous improvement or lean engineers. So this particular skill or knowledge will be very, very useful for you to get a job in the manufacturing sector, and you will be able to perform better in your interviews, and you can land in your dream job or high paying jobs. If you are a working professional, you can lead the lean projects in a better way, because now companies are nowadays due to this COVID, due to the cost reduction, they're not giving a lot of training, right? If you are from a medium scale enterprise, there is not a lot of training which is happening. So now you have to learn the concepts yourself, and this particular program will help you so that you can also lead the projects in a better way. You can show the results in your lean projects, and again, this is a time for us to upgrade ourselves, and we can go in that faster career growth, right? So this is why this particular session is important. And what are the things we are going to cover in today's session? I'm going to talk about a little bit about lean manufacturing, the basics or the history, I would say, and then we are going to differentiate between work and waste, and then the 7 types of waste in any manufacturing company. That's what we are going to learn in detail. And what is the biggest poison which is present in every company? Right? We call it as the mother of all the waste, the biggest waste. Right? That's what we are going to learn today. And finally, at the end of the session, I'm having a gift for all of you. Right? People who are sticking with me till the end of the session, you'll be getting a gift. So let us start. And yes, there are going to be a lot of action points for at the end of the session, which you can go and implement in your company. Right? So let's get started. The first session is about the history of lean manufacturing. What is lean manufacturing? Right? Lean manufacturing is a set of management practices that originated in Japan, which are useful in eliminating non-value added activities. Right? Elimination of non-value added activities. That is the first thing which I have underlined. And improving the productivity in a faster and efficient manner through the pull of the customer, right? And continuous improvement. So pull of the customer is the second key term, and the third one is continuous improvement. These 3 are the major foundation, I would say, for lean. Right? The first one is elimination of non-value added activities, and the second one is pull of the customer, and the third one is continuous improvement. How can we improve continuously? So the first point, that is elimination of non-value added activities, is what we are going to cover today. All right. And what is the history of this lean? Right? It started with Toyota in the year in 60s, 50s and 60s, and Toyota, they have perfected it over the next 20 years. Right? And in the 90s, the Western world tried to adopt the same philosophy for their manufacturing, and they have renamed it as lean manufacturing. But what we are talking about lean is essentially the Toyota production system. I will give a quick history. After the World War II, Japan lost the war and they tried to rebuild the economy. Right? And for any economy to increase the GDP or to improve the economy, the country has to start manufacturing. That's how at that time during the industrial age, that's what is the key thing. So Japan also started manufacturing automobiles. And during that time, there is no technology in Japan for manufacturing automobiles. So what they did is they started, the many companies which were earlier in other businesses. For example, Toyota used to be in textile industry, textile machines, the power looms. Even now, if you say most of the textile machineries are from Toyota, they are the world leaders, the power loom. So companies like Honda, Toyota, Suzuki, all those companies, earlier they were in other manufacturing, other products, and they started manufacturing automobiles. And during that time, there is no technology. So Toyota's chairman at the time, he visited American car companies, the big three companies, right? General Motors, Ford, and Chrysler. So the Toyota's chairman, he visited America to get the technology. And when he visited the American car companies, right, what he saw was a lot of inefficiency in the system. Right? American cars at that time, if you see in 50s and 60s, they were all huge cars. The big engines, gas guzzlers. Because America won the war and the price of petrol or gasoline was very cheap, and all the cars at that time used to be very big. Right? So when he visited these American car companies and he understood the manufacturing process they follow, it's a typical mass manufacturing, but without any flexibility. They will continuously run the production, and for example, if it's a body part, the door part, let's say, the stamping will happen, and they continuously manufacture the stamped parts, and they will have it in the warehouse, and they will not change the setting, right? For weeks and months, it will run the same product. So there is a lot of WAP. For holding a lot of WAP, they will have separate warehouses to store the WAP. And new cars were launched only once in 10 years. The product variants, and setup time was very high. The plant requires a lot of space. So when he visited all these things, right, he understood that this kind of manufacturing will not suit Japan, because Japan is a very small country. They don't have a lot of land. They don't have the infrastructure at that time. So what he understood is, we have to build a small factory where everything happens within that factory, and it has to be flexible. So whatever I need, I have to produce at that time and ship it. Right? So they started manufacturing in a slightly different way, right, with reduced WIP, through just-in-time production. Whenever the next process asks for material, at that time only it will be done, running small batches by reducing the changeover time. Right? Faster development of cars. Right? New models were released more frequently, producing the right quality of products at the first time itself. The first time right. When I do the product, I have to do it first time right. That's what they follow, so that reworks are reduced. And all these activities means the Japanese cars, they became more reliable, and they give more mileage also. So in 70s and 80s, the Japanese cars, the market share started increasing in America. Right? So people started liking those cars. These cars are small cars and reliable. They don't break down, right, frequently, and they give more mileage also. So people started liking these Japanese cars, and in 80s, the share of Japanese products, they increased in America, and people call it as a second, the Japanese invasion. And now the American car companies started worrying, and they were like, no, these guys started the production based on our factory, but now their cars are superior, right? So we have to learn what they are doing. So in 90s, right, in 1990s, the American car companies, they funded a lot of research. Universities like Wharton, Stanford, all those, the university researchers, they were funded to learn the Japanese manufacturing. So these researchers, they went to Japan to understand how these cars are manufacturing, and they understood that this Toyota has a unique philosophy, having a lot of these tools, and they named it as Toyota Production System. So they adopted all these things, and they went back. I mean, the researchers learned all these things, and they went back in 90s and 2000s, and they started taking to this American car companies. They became the gurus of Toyota Production System in the US. People like Jeff Liker, Martin Schuck, all those people. And in 2000s, it became lean becomes a very, very famous thing in America. All these big companies, Ford, GM, Chrysler, everybody started adopting this lean manufacturing. But when they want to adopt this philosophy, they cannot call it as Toyota Production System inside a Ford plant, right? They cannot use the name Toyota because it's a competitor. So they want a different name. So they coined a name called lean manufacturing. But essentially, it is Toyota Production System, which is called as a lean manufacturing. And now, after 2000s, it also became very famous in India. Companies like Hero Honda, TVS Group, because they already have a Japanese connection. Hero has a tie-up with Honda. So obviously all this technology, all this knowledge will come to India, right? to Hero Honda. TVS also, they were manufacturing automobiles. So the early adopters, if you say TVS, Hero Honda, and other automobile companies, they started this lean manufacturing in India in 2000s, and now in the last 10 years, other industries also started adopting lean manufacturing. So this is a brief history of lean manufacturing. Essentially, it is Toyota's manufacturing system. The concepts which were evolved in Toyota, I would say. Is lean applicable to all the industries? Yes, lean can be applied to all the industries. Automotive industry, they are already following a lot of lean philosophies. Machine shops, castings, forgings, plastic components, fabrication, medical devices, leather, footwear. We have done a lot of leather and footwear implementation on lean. Food processing industry, they follow lean. So it doesn't matter whether the company is small, medium, or large. Lean can be applied to any size of companies, and it can be applied to service industries also. Nowadays, a lot of hotel chains are using it. Logistics is an industry which has taken or embraced lean in a big way. In Europe and US, if you see, there are a lot of hospitals, restaurant companies, they're all started using this lean principles nowadays, right? So this is a brief history of lean. Are you clear with the introduction? Can you type yes in the chat box if you can understand my explanation? Is it clear? Am I going too fast or too slow? Right? Is it clear? Yeah, great. I can see a lot of yeses. Thank you. Thank you. So now let us look at the difference between work and waste. We saw the first slide, the elimination of non-value-added activities, right? That's what we are going to look at now. So there is a big difference here between work and waste. To understand lean, we need to understand this work and waste. I would say this is one of the most important realization that is required. Why I am not saying the word knowledge or skill here, I am saying this as a realization, because you have to get it, right? It's like you cannot learn it. You have to see it, right? You have to realize that the difference between work and waste, and that's what I'm going to try teaching you today, right? You will realize what is work and waste. That's what is the most important foundation, right? Even in our consulting programs, this is the first foundations we create. People should be able to identify the work and waste, right? Once you identify the waste, you will come out with easy solutions to eliminate the waste, right? That identification is the critical thing. Yeah. So let me give an example how we can look at it. Yeah. Let us consider two people. One person is a obese person, right? One person is a obese person, and another person is a lean and a fit person. So a obese person has a lot of fat in his body, right? And a lean or a fit person does not have a lot of fat, but he has, let us say, a lot of protein in his body, right? So the obese person has lot of fat, and the lean person has a lot of protein. What are the common problems faced by this obese person? They have this lack of stamina, they have issues, health issues, probability is there, high BP, cholesterol, heart problems, they have difficulty in walking, running, etc. Right? So these are all some of the challenges faced by this obese person. And if the obese person wants to become lean, what is that he can do? He can do exercises, he can do diet control, jogging, walking, yoga, right? Nowadays there are medical procedures like liposuction. They remove the fat, they suck out all the fat from the body also. So these are some of the ways by which this obese person can become a lean person. So what we are trying to do here, we are trying to eliminate the fat, right? Eliminate the fat from the body. That's what we are trying to do. So similarly, all the companies also, they have a lot of fat, right? In companies also there are a lot of fat. If we remove those fats, the company also will become a lean company, right? Today, what are the symptoms for this fat company? The company is not able to deliver on time. There are a lot of quality problems, right? People are always frustrated. They're running around firefighting, a lot of product mix-ups, right? Unable to meet the production target. All those things are the symptoms or the results. But what is the cause? The cause is there is a lot of fat in the operations. If we remove those fats, the company also will become lean, and it will be able to meet the customer demand, produce better quality, meet the production target, right? People will work happily without any frustration. So these are all the results. So protein means, let us take it for in our example, let us say protein as work and fat as the waste. So we can eliminate waste, right? We need to eliminate the waste so that the overall work percentage, the protein percentage increases. That's what we are trying to do. We are going to focus on the fat. So now, in a company context, what is work? Right? Work means whenever there is a physical or chemical change in the product, it can be called as a work. Whenever there is a physical or a chemical change, the key word here is change. There is a transformation. Right? Sometimes the transformation will be physical, right? In a turning operation, let us say you are doing a turning. So during this turning operation, there is a physical change in the diameter, right? So you can see that, you can measure it, physical change. Sometimes it may be a chemical change. What is a chemical change? For example, if you are doing a heat treatment, annealing, nitriding, in that time, the change will be chemical change. There is no change in the physical dimension. The product dimension will be the same, but the internal grain structure will change, right? In heat transfer. Similarly, during a painting, after painting, the paint has to cure, right? It has to become solidified. So it will take, let us say, 20 minutes or 30 minutes, depending on the glue. Depending on the paint. So during that time, there is a chemical change that is happening. There is no physical change. The product looks as it is, right? But there is an internal change. The chemical change is happening. So that can be also called as a work. So work means whenever there is a change that happens in the product, it can be called as a work, because there is a value addition that is happening. Whenever there is a change, you are adding some value to it, right? You will not sell the same product in the same price, right? The raw material cost is 10 rupees. Now I am doing some value addition. There is a change now. Now I will not sell it at 10 rupees because I have added some value. I will sell it at 12 rupees or 15 rupees, right? So there is a value that has been added. So it can be called as a value added activity. So now work is very clear for us. Whenever there is a change, it is work. So what is a waste? Very simple. When there is no physical or chemical change, it can be called as a waste. The product, in that particular product, there is no change now. Whenever there is no change in the product, it can be called as a waste, because we are not adding any value at that time. So it can be called as a non-value adding activity, right? This non-value adding activity or the waste means when there is no physical or chemical change. Are we clear? If you observe carefully, more than 95% of the time a product spends inside the factory would be waste. More than 95%. This is true across all the companies. Less than 5% would be the real value adding activity, the real transformation, the real change that happens for less than 5%. Let me give an example to you. Let us consider a batch manufacturing, a stamping operation, right? And the batch size is 1000 pieces, right? So in this stamping operation, we are using a press, right? And the value added time is just at 1 second when the press comes and hits the component, right? When the punch comes and hits the component, there is a deformation, there is a change in the product. So the value adding time is just 1 second. And what happens after that? This particular product goes into the bin, right? And the batch size is 1000 pieces. Now, the remaining 999 pieces have to be completed. Then only this bin will go to the next operation, right? So in this case, the value adding activity is 1 second. The waste is 999 seconds of waiting, because this product is now waiting for the next 999 pieces. Till that time, there is no other value addition. It is just as it is sitting inside that bin, correct? So this is an example. Right? Let me also play a video for you now. Right? I will play the video. You will be able to identify the value adding time and the non-value adding time. Right? I am playing the video now. So the guy has loaded the component, he just kept it, and now the wheel is coming down. What is the value addition? Whenever the wheel touches the component and cuts it, that is the real value addition. That's the transformation, because we are reducing the size of the product, right? The overall length. Now the machine is stopped. The excess piece is still there. Machine is stopped also. if you look at this particular video plays for about 18 seconds, in that the value addition is just 5 seconds. That's the time when the wheel goes into the component, cuts it, and then comes out, right? The wheel was in contact with the product only for 5 seconds, and the remaining time is waste. Are we clear? Is it clear? Can you understand the difference between work and waste? If you are able to understand, can you type yes in the chat box, please? This is the most important thing. Everything you look at in this particular view, right? Whenever there is a physical or a chemical change, it's a work. Whenever there is no change, there is no work. That's all, right? Some people call that so you may be asking that loading, unloading, is it important? Can I eliminate it? We will come to that, right? But be very clear. Whenever there is a value addition, whenever there is a physical or chemical change, it is work. Whenever there is no change, there is no work. That's all, right? Very good. Thank you. So now, can you take your notepad, list down the work in your operations? Just list down what are the work that is happening in your company, right? It can be an activity like drilling. So if you know that cycle time, for example, drilling activity takes 1 minute. Then there is a stamping activity, let us say 1 second. Then there is a turning, heat treatment, whatever. You look at your operations. Can you just list down the work which is happening in your operations? I'm going to give you 1 minute for this. Just take your notepad and you can do this exercise. So 1 minute for you. Just think about your work and write it in the notepad. What are the activities, value adding activities in your operation? If you have completed, type DONE done. Type done if you are through with the exercise. Thank you, Mr. Pankaj. Mr. Ankit Sinha, thank you. Mr. Darshan, thank you. Mr. Abdul Rasaf, thank you. So Pankaj, you can type in your in the chat box. You have raised your hand. I saw that. Can you type in the chat box, please? If you have doubt or something, you type in the Q&A. We will answer that in the Q&A. So Charan, thank you. Mr. Sadish, thank you. Mr. Mauli, thank you very much. So I hope you have completed the work, right? So this works. Anybody has written inspection in that? Anybody has written inspection in that work? Think about that. Inspection, is inspection a value adding activity? Is inspection a work or waste? I hope you have not written any inspection. All right. So, okay. So Mahendran says work inspection. Charan says work is inspection is work. Okay. Let us discuss this later. Yeah. All right. So let us go to the 7 ways now. Yeah. Let us go to the 7 ways. See, nowadays people, if you look at a lot of articles, they talk about 8 ways. There are like 8 ways. They say they have added one unused skill or knowledge of people also, right? That has a 8th waste in the system. But for this presentation, this session, let us focus on the 7 ways. Okay. So the 7 ways can easily be remembered as TIMWOOD, TIMWOOD, right? So in any company, these 7 ways will be present. These are all the areas, these are all the instances in which there is no physical change or chemical change happens to the product. There is no change to the product in any of these 7 ways. That's why it is called as the 7 ways, right? Let us look at these 7 ways in detail. The first one is transportation waste. The first one is transportation waste. Transportation is moving the product from one place to another place, right? Transportation means moving the product from one place to another place. In other words, no, during transportation, is there any physical or chemical change that happens? No, there is no physical or chemical change. The product just moves from one location to another location, right? So there is no physical or chemical change here. Is it possible to completely remove the transportation waste? No, we can't remove. Anyway, the product has to transported from one machine to another machine. It has to be transported from the company to the customer. So the transportation will be there, but it can be reduced, right? So the transportation can be reduced. It cannot be completely eliminated. When in India, if you see, there are many companies where they would have started the work, let us say 5 or 10 years before, and during the time they had a particular layout. And after the company started growing, they would have bought a lot of new machines. And during that time, when the machines come, they don't want to disturb the existing layout, so they will place the machines wherever possible, wherever there is space, they will try to locate the machines. After some time, if you see, there will be a lot of this zigzag movement of product. And the transportation also has a side effect. It creates batches. Because the machines are located far away from each other, I cannot give the product one by one, right? So what I have to do, I have to necessarily create bins. Then I will have to create a batch size, right? Batches. And then I have to use material handling equipment like trolleys, forklifts, etc. Because the machines are located far away from each other. The processes are, then the next process is at a distance. Sorry. So I cannot have one by one, single piece flow. So now I am creating a batch. Now I need all these material handling equipments. Are you clear? So transportation is the first waste. And whenever you see a lot of materials, right, in the shop floor, a lot of WEP located in bins, you can clearly see that the transportation waste is high. Right? Now in the notepad, can you take 1 minute to understand the transportation waste? Right? In your operations, you are already listed out all your work. So in between this first activity and second activity, first work and second activity, what is the transportation? Can you identify the transportation in your organization? Can you take 1 minute and identify transportation? Where the machines are at a distance, the processes are at a distance away from each other. Yeah. Can you take 1 minute and complete this? Yeah. Identify the transportation waste in your company. Yes. Thank you, Mr. Anand, Mr. Patel. Thank you, Mr. Sendil Kumar. Thank you. All right. Good. So now the second waste is called as the inventory waste. Inventory is the stock which we bought for the company, right? The inventory is the materials which we bought. And you may be thinking, how can it be a waste? When the material is stored as inventory, there is no transformation. Is there any physical or chemical change? No. The product is just as it is, right? In your raw material stores, it is as it is. When the material is as WIP, work in progress, in between the process, there is no change. When the material is lying as finished goods, there is no change, right? So Inventory, during this inventory stage, there is no change in the product. So we are calling it as a waste. Again, can the inventory waste be completely eliminated? There are companies, people are looking at reducing that. We are looking at optimizing the inventory. For example, if you take automotive sector, most of the automotive OEMs, original equipment manufacturers, they try to have the stock, raw material stock in their vendor's location itself. I'll give an example. In Chennai, we have the Hyundai plant, right? So the Hyundai plant is surrounded with their own suppliers, the tier 1 companies, right? All these tier 1 companies are located in the same area, same industrial estate. So whenever the Hyundai requires the materials, during that time only the materials will be reaching the factory, Hyundai's factory, shop floor. Again, the materials will not go to a store, then somebody will check it and then only it has to be issued to the shop floor. No, it's not like that. The materials from the vendors directly reach the shop floor of Hyundai, and they call it as a supplier self-certification. The supplier has to certify the materials for the quality as well as the quantity, right? So in this way, a company like Hyundai, they are able to reduce their raw material stock. Again, if you look at, if they want to have at least even one shift material of all the parts, it will be very high. Let me take an example. No, let us say they're in one shift they produce 2,000 cars, right? I think they will be doing 2,000 cars per day, per shift. So for every car, let us say one particular product in that car, tires, let us say, right? A car requires 4 tires, which are assembled in the shop floor, and then one more tire goes as a stepney, right? So each car requires 5 tires, let us say, and if they produce 10,000 cars per shift, 2,000 cars per shift, how many tires we need? 10,000 tires we need. And imagine the space required for storing this one shift material, right? 10,000 tires. How much would be the space required? It's very high, right? That I'm talking about only one product now. Imagine there are thousands of products like that, right? So it is always better for these OEMs to have their vendors located nearby so that they can get the materials as and when required in the shop floor. They call it as a vendor self-certification. The logistics, because somebody asked about logistics, there is a concept called milk run, where the truck will go to different vendors, pick the materials which are required, and then comes to the factory at the right time. So in this way, the companies are able to reduce their raw material stock, right? So whenever you see a lot of material, raw material or WIP or finished goods, we can identify that this company has a lot of inventory waste, right? Can you identify the inventory waste in your company? There is one more reason also which will increase the inventory, that is called as high setup times. So many times people don't understand the correlation between setup time and inventory. If the setup time is high, right, the changeover is high. Let us say it takes 5 hours for a changeover or 8 hours for a changeover. What people do is they try to avoid this changeover. They don't want to do the changeover frequently. So what I do, I run this particular setting for 1 week. The same product I will produce more and I will keep it because my setup time is high and I don't want to do frequent changeover. Because the setup times are high, I will also produce a lot of inventory, WIP, work in progress, and store it. So setup time also has a correlation with high WIP, right? So in the next 1 minute, can you identify your inventory position? What is your typical raw material stock? Is it high or low? What is your work in progress? Can you identify the WIP status between your operation? And also the FG stock, if you are having more stock, right? Can you identify in your organization? You can take 1 minute for this. Just think about your inventory waste and complete this exercise. FG stock means finished goods stock, materials which are ready for dispatch. I made it ready and and packed it and ready for dispatch. When the truck comes, I will load it and send it. That's called FG stock, finished goods. So RM means raw material, WIP means work in progress, FG means finished goods. Is ready for dispatch. Yeah. Mr. Patel says done. Okay, thank you, Mr. Patel. So Suraj also done. Thank you. So Satish is done. So Pankaj, thank you. Sendil, thank you. All right, thank you. So let us go to the third waste. The third waste is called motion waste. Motion means any movement of people, right? People movement that does not add value to the product. Whenever people move in the factory, are they adding any value? They're not adding any value, right? People just move here and there. Sometimes they take the materials and come. So the transportation as well as movement happens together. If you look at the first waste, that is transportation, that is material movement, and the third one, motion waste, is people movement, right? So what are the instances for people to move in the factory? They move to take the materials, right? They search for tools and materials. Excessive reaching or bending. For example, there is a big machine where they have to do a changeover. They have to go here and there, right? They'll be walking here and there. Sometimes people will climb on the machine. The part has to be, the adjustment has to be in the top, so they have to climb up. People sometimes load the component or store the component in the floor, right? If I am an assembler, assembly section operator, I complete an activity and then if I keep it in the floor, right? I have seen this one company. The person, the operator, after assembly, is putting the component in the floor. The bin is in the floor, right? So every time he completes, he has to bend and keep the material in the floor, and he's doing it for 500 times a day, right? So he's doing 500 times bending, and what will be the fatigue, right? What will be the tiredness for that person? Will his productivity will be good? No, obviously he will get tired too easily, too fast, right? So whenever there is people motion, people walking here and there, right? It's called as a motion waste. And sometimes the operation will not be ergonomically suitable. Ergonomic means the way you sit, right? It will create a lot of fatigue or tiredness or body pain. People I have seen in the loading and unloading section. Most of the Indian companies, the medium-sized companies, they have human beings, I mean manpower to do this loading and unloading. They have to carry heavy loads and load the truck. Load in the truck, right? So most of the times I have seen people falling down, or they put the component in the floor, so that the product get damaged because of fatigue, tiredness, right? So this is called as a motion waste. So can you identify this motion waste in your company? People movement. What are the areas where people are moving here and there, or they are carrying heavy loads? Zigzag movement of people also, bending, poor ergonomics. In your office, in your operation, can you identify what are the motion waste in your company? Take 1 minute and you can complete this exercise. Typically loading, unloading will be there, if you see. Type done if you're through. What are the instances here you can find this motion waste? Shall we go to the next one? Next waste? Yeah. Thank you, Vinay, and thank you, Mr. Charan. Thank you. Yeah. Next waste is called the waiting waste, fourth waste. The waiting is the idle time in which no value addition takes place to the product. When there is no value addition to the product, it can be called as a waiting waste. Imagine there are three resources: people, machine, and material. Right? When one of these resources is waiting for any of the other two resources, it can be called as a waiting waste. Right? When one of the resources is waiting for any of the other two resources, it can be called as a waiting waste. Some common examples, if you can see, are machine breakdown. When there is a machine breakdown, what happens? Materials are waiting for the machine. Similarly, manpower also waiting for the machine. When there is a changeover, what happens? So during a changeover, the materials are again waiting for the machine. Manpower is also waiting. Right? And when there is absenteeism, machines are available, materials are available, but manpower is not available. Sometimes the materials are not available, right? People are available, machines are available. I don't have the raw material, right? So when one resource waits for the other resources, can be called as a waiting waste. How will you identify this waste? When people watching the machine run, in a CNC operation, let us say, The person has loaded the component, closed the door, switch on the process, right? So the machine started working, and now he will be just standing and watching the machine running, right? And if the cycle time is 1 minute, this person will be just standing and observing, just looking at the machine running for 1 minute. That is also a waiting, right? And materials located in bins and storage racks, again these materials are waiting for the next operation, right? And changeover, breakdown, all these things are instances of waiting waste, right? So can you identify the waiting waste in your organization? Breakdown of machines, setup time, non-availability of material, people watching the machines running, all those things. Can you identify this waste? See, the first exercise you have done is the activity or the work. For every work, there will be some waste. For example, there is a CNC turning operation. That is work. For this particular work, there breakdown of machine may be there, CNC breakdown machine may be there, setup time will be there, right? So all those things will be there. So one work will have many wastes, right? And this is the fourth waste. Just connect it to that particular work. Okay? Take 1 minute and you can complete this exercise. Identify the waiting waste in your organization. What are the instances of machine breakdown? Yeah, thanks, Mr. Patel. Thank you. It's a non-availability of materials will be there. Sometimes breakdowns, setup time, that setting change, all those things. Yeah. Thank you. So now we are looking at the fifth waste. The fifth one is called as overproduction. Overproduction means producing more than the required, producing more than the requirement. There are two levels for this. The first level is producing more than the external customer's demand. That is, external customer means what? The person who is paying the money and getting the products, right? So companies sometimes produce more than the external customer's demand. For example, if it's a garment, a shirt manufacturing company, right? The company is getting an order for 10,000 shirts. So what they will do is internally they will produce, or they will plan to produce for 10,100. Why this 100 extra? Because they may have some internal rejections, all these wastages which happens in the process. So they try to produce a little more. So what happens at the end of the order? Instead of 10,100, the company will have good pieces. Let us say 10,050. The another 50 pieces are gone as a waste, defects. So now the company has 10,050 pieces. The company got an order only for 10,000 pieces. So the customer will buy this 10,000. What will happen to the remaining 50 pieces, which are good pieces, that will go as a discounted sale, right? We have seen that in many online platforms, discount shops. It will come to the discount shops at a lesser price, right? So this is called as overproduction based on the external customer's demand. And then there is another overproduction which happens at the internal stage, producing more than my internal customer's demand. Who is my internal customer? The next process is my internal customer, right? So if I produce more than my internal customer, that is also called as a overproduction. Let us take an example. There is a product, there is an operation A and B. Operation A's cycle time is 1 minute per component, and let us say B cycle time is 2 minutes per component. So how much operation A will produce in 1 hour? A will produce 60 pieces because the cycle time is 1 minute. So A will complete 60. B can produce only 30 because cycle time is 2 minutes. So what will happen in between A and B? 30 pieces will become a WAP, work in progress, right? So in this case, A is overproducing. A is producing more than B's requirement. B is requiring at 2 minutes per component, but A is producing at 1 minute per component. So I am producing more, right? So what will happen if I produce more? The component will end up as WAP in between the process, correct? So this is called as overproduction, overproducing more than the internal customer's demand. Whenever you see WAP, work in progress, in the company, which means there is a clear overproduction happening in the operation. Sometimes people will buy machines, right? No, if they, I have seen it in food processing industry, right? The company wants to invest in a small machine, right? They have, let us say, 1,000 ton per month, no, machine they want to buy, but in the market it will, the machines are available only for 10,000 tons per month. 1,000 tons, let us say, it's a very small capacity for that, industry. So they don't have any machines. So the company will obviously have to buy this 10,000 ton machine, right, in a month. And what they do, because they bought a big capacity machine and they cannot use it only for small limited time, so they keep on producing. They don't want to keep the machine idle, so they just produce and keep it as WAP. This also I have seen in many companies, right? So whenever you see a lot of work in progress, WAP, whenever there is an imbalance, line imbalance, the cycle times are not matching, it means we have a clear overproduction, producing ahead of the demand, right? Or producing big lot sizes, batch production. All those things will lead to overproduction. Are you clear? Overproduction. Can you identify this waste in your organization, the overproduction waste? Producing more than the demand, line not balanced, high WAP, right? Can you see this in your operation? Take 1 minute and you can complete this exercise. Take 1 minute and identify this waste in your organization, overproduction. Whenever you see WAP, you will see the overproduction. If you are through, you can say, you can type done, DONE, if you are completed. Thank you, Mr. Abdul. Mr. Patel, thank you. Thank you, Jeffrey, thank you. All right. Senthil Kumar, thank you. Mr. Charan, thank you. Krishnan, thank you. All right. Let us come to the next interesting waste. This is my favorite waste, I would say. Over processing waste. Over processing means what? Processing more than the requirement. Okay, the efforts or activities that are added to compensate for some of the inefficiencies in our system. Right? These operations, the customer does not ask. We have added ourselves. Why we have added? Because to compensate for some inefficiencies in our operations. Right? These activities, they do not add any value, but they look like a value-adding activity. It is in a disguise, right? We may immediately think it is a value-adding activity. We may misunderstand that. We think it is a value-adding activity, but if you really analyze closely, these activities are actually non-value-adding activities, and it is very, very difficult to identify them. Right? Some people said no, inspection. They thought that inspection is a value-adding activity. Okay, are we adding any value are we adding any value during inspection? Inspection is a process where we are only segregating the good pieces and bad pieces. We want to make sure that the bad pieces don't go to the customer. That's all. Is there any change that happens in the product during inspection? No. The defect originates in the process. And after the process is done, I am sitting separately and segregating good pieces and bad pieces. So is there any value addition? There is no value addition, right? So inspection, is it a value adding activity? No. But can I completely eliminate it today itself? From tomorrow I will not do any inspection. Can I say that? No, because your process is producing defects. If you don't do inspection, all the bad pieces also will go to the customer. So today my process is producing both good pieces and bad pieces. That's why I'm doing inspection. But if my process does not produce any bad pieces, if it produces only good pieces, right? After some time I don't have to do any inspection, no? Because there is no defects which is going to come out from the process. There is no need for inspection. Are you clear? So that is one level of over processing. Right? I will tell you another example in garment industries. I don't know if somebody is from garment industry here. They will do the cutting activity as a laying, as a batch. No, the cloth will come in a roll, right? And they will lay it. There is a laying operation. We call it as laying because they will spread the cloth one layer above the other layer, right? And then they will cut it in a batch. No, using a cutting machine, they will cut it in a batch. And then, let us say there are 100 pieces, 100 layers. So after cutting, no, you have different cut pieces in 100 batches. For example, if you take this shirt, there will be like, let us say 15 15 pieces, I don't know, 15 pieces. Collar will be there, this shoulder piece will be there, the front side will be there, pocket will be separate, the hand, the hand will be separate, and then the cuff will be separate, like that. So different pieces, but all in 100 numbers. What they will do is, to meet the sequence number, the first layer, right, the first layer of garment should have the same, for example, if this particular piece is from the first layer, the hand piece also should be from the first layer, the collar piece also should be from the first layer, because then only it will match, the color matching will happen. Otherwise, if I mix it up, sometimes there is a possibility of color mismatch. So what they do is, they have to ensure that the serial number are matching. So what they do is, after cutting, they will do a stickering activity. In all these 100 pieces, they will put 1, 2, 3, 4, 5, like that. Similarly, in the other next piece also 1, 2, 3, 4. Collar piece also 1, 2, 3, 4, like that. So what they do is, the first pieces all will go into the first shirt. The second number pieces will go into the second shirt. Like that, they have to ensure. Is this stickering activity, if you look at it, we may look at it as a value adding activity. But the sticker will be peeled off. It will be removed in the line itself. At the end of the line, they will remove it. It will not go to the customer. The customer doesn't ask for the sticker. All the customer asked is a good quality shirt. That's all. But what we did, we have created a process called stickering activity, and we are doing it on one stage, and we are removing it at the later stage. Clear over processing. Are you understanding this? I'll give another example. There is a company where we work. It has multiple sections. So the first section people, they will complete the work. They will do a counting. They will do an inspection, and they do a packing. They pack the product because it is a very shiny object, so it should not get scratches, right? So they will pack it. The second section people, when they take the material, they will again count it. They will again do an inspection. They have to remove the pack, and then they will use. And then when they are giving to the third section, they will again do a counting, inspection, packing. So multiple stages of counting, inspection, packing inside the company. Why? Because we don't want to, because the current processes are creating some inefficiency, having some inefficiencies like scratches, it may happen. The counting is mismatched. The product is not of good quality. So still I am getting bad quality products from the previous section. So what I am doing, I am now added one more counting, inspection. So all these things are clear over processing activity. In some companies, I will do a nut tightening in a product. Let us say I have tightened a nut in the first stage, and in the fifth stage, that same nut has to be loosened, and then they will add another product and again tighten it, right? So I have tightened the nut in one section, loosened the nut, and added another component, then again tightened the same nut. Clear over processing. Yeah. Can you identify this over processing? Right? Can you identify this over processing in your organization? Multiple level of inspection, packing, unpacking, all those things. Yeah. So now people are talking about asking inspection. No, inspection. You don't add any value, correct? Right. So some people ask, is inspection considered in over processing? See, today I am doing inspection because my process is producing bad quality product. That's why I have to do inspection. I am not asking you to stop it from today. No. The moment your processes are strong, that it does not produce any defect, you don't have to do inspection. You can do random sampling, right? So I have seen companies where doing this 100% inspection. Even after 100% inspection, there will be a lot of defect. Yeah, is 100% inspection solved your problem? No, you cannot, because human beings cannot do 100% inspection. Very, very simple. By putting more and more people for inspection, by putting more and more stringent quality inspection, you cannot reduce any defect. You can only reduce it, you cannot eliminate defects. So Jeffrey says, yes sir, over processing is happening in my father's work. So is he working in some company or he's running some factory, Jeffrey? So Patel Rupesh says, yes, done. Thank you, Mr. Patel. So Vinay says done. Thank you. This is a very interesting ways actually, over processing. Many people think it as a work. For example, all the industries have that. No? If you take any industry, it will be there. No, I will apply grease in one area and then excess grease I will apply, and at a later stage I will remove the excess grease. All those things. The seventh ways we all know, the defects, right? The defects which are created in the process, like producing defective components is a waste. Let me ask you this: what is the difference between defect and defective? Right? Are they the same? Defect and defective, are they same or different? What is defect? What is defective? Defect and defective, are they same or different? Manoranjan says no, which means it is different, right? Can you explain what is defect and what is defective? Yeah, you can explain in the chat box. What is defect and what is defective? What is this? Jeffrey is saying defect is identified. Okay, defective is thing is defected. What is that? What is that, Jeffrey? Defect is defect is the phenomenon on the product. Okay. So Anand says, Mr. Krishnan says defective can be reworked. So defect cannot be reworked, is it? Mr. Ankit says different. In one piece shirt, many defect and the piece is defective. Yes, good Ankit. Thank you. Thanks for the explanation. Yes, Ankit has given the right answer. Let me read Abdul Razak. A defect is any item or service that exceeds the departure. Okay, correct. Defect does not necessarily the product. The defect is the product is 1 minute. Hold on. It's scrolling, going up. All right. Defect is counting, defect is uncomfortable. I think Ankit has given the right answer and Abdul Razak also given the right answer, correct? Yes. No. Onkar Dumal. No, defect we can't rework, defective we can't do. No, not that. Let me give an example. Two people have given the right answer, Mr. Ankit and Mr. Abdul Razak. Now let me explain. Defect means when there is a difference in the specification. The customer has asked for something and there is a non-conformance, right? The product, there is a non-conformance. It is not meeting the specification. It is called as a defect. For example, if it is a shirt, garment manufacturing company, let us say there should be buttons, right? And let us say there is one button which is missing. The button missing is a defect, right? So it is against the specification. Let us say they have to use a white color thread. Instead of a white color thread, they are using a red color thread. That means it is a defect. So anything which is not meeting the specification is a defect. And because of this defect, right, because of this button missing, this shirt has become a defective shirt. The product which you are manufacturing is a defective product, right? The point which is not meeting the specification is the defect. So a defective shirt can have one defect or more than one defect also. Right? The same shirt, the button can be missing, the thread color can be different, the collar size can be different. In size 40, they have put the size 38 collar. So it is a mismatch. So it is against the specification. So the third defect is collar mismatch. So one defective shirt can have multiple defects also. Are we clear? So it is not about rework or reusing, right? Defect means anything which is out of specification, which is not meeting the specification is defect. The product you are manufacturing is called defective product. In a casting industry, blowhole is a defect, crack is a defect, right? And scratches may be a defect. And because of these defects, the product is a defective product. That casting which you manufactured, that has become a defective casting. Right? And many companies, what are you measuring in your companies? Are you measuring the defect or defective? Everybody will say defect. Yeah, because they say, okay, I have noted down the defects. But in reality, in the inspection stage, when the inspectors, when they are analyzing a component, the moment they identify the first defect, they will keep the components separate. Right? I have taken a product. I am measuring it. There's a scratch here. So there's what I will do. Product number. No, there's a scratch, one number. But the same product may have another defect also that they have missed out now. Right? So what are you measuring? Defect or defective? Many people think that they are measuring the defects, but instead they are measuring the defective. So all your Pareto analysis, your quality analysis, all those things will go for a toss when you are measuring clearly the defects. Right? Your entire analysis may change. Your top 3 defects may change. All right. So let us come back to this. Defect means, okay, producing a defective component is a waste, and because why? Because it has to be reprocessed again. It requires a lot of effort, time of people. Sometimes it happens within the company. At least it is okay, manageable. Sometimes it goes to the customer end, so we have to send some people to the customer, and then segregate it, do the replacements, and come. Sometimes the product reaches the end customer also, right? In cars, if you see, I bought a car. It happened in my last car experience, the previous car which I had. I bought the car in 2010. Okay, and in 2011 or 12, I got a mail and a letter from Ford at that time. Right? They said, no, okay, if you have bought the car on this date, and we are doing a recall, product recall. You have to take your car to this workshop. They will check for the particular defect, and if there is a defect, they will replace that particular product free of cost. How much time it will take? Customer has to take the product to the dealership. They have to analyze it now, do the replacement, all those things, right? So any defect, we can do sometimes rework, sometimes it cannot be reworked also. But the thing is, our focus should be do it first time right. That should be our focus. So the 7th waste is defects. Can you identify the defects in your organization, the rejection, rework? I think this is standard. Every company will have this data, right? What is your typical rework rate? What is your rejection rate? Can you note down in the notepad? Okay, just do this exercise in your notepad. So Anand says that's what I express to. Yes, okay, good. So defect is different, defective is different. Very good. Table inline checker. Table inline checker, table both can see. What is that? I think you are also, Mr. Ankit, you are also from the garment industry. I think table inline checker means, I think in the garment industry, at the end of the line, there will be one checker, right? I think you're saying about that. Good. Yes. I am now working with a garment unit where we are reducing the WIP, and now the company's typical garment industry, the lead time for an order will be about 120 days, 90 days to 120 days, 120 days. Now we are getting this company. This company is specialized in doing a short run, small run and shorter lead time. Now we are dispatching the materials in 45th day, right? 45th day, order is getting completed. And the customers are willing to pay more for that. Some customers are willing to pay more. It's a premium kind of business. Thanks, Mr. Patel. Everything is we are planning as a single piece cutting. Cutting is also small laying, small batch laying. Immediately, then the lines will be very close. So we are going to give this to the line. Line is a continuous flow, U-shaped line with hangers. So there is no bundle system here. So everything is hanger. I'm talking about the garment industry for some people here. So there is a hanger system. From the hanger, we are directly saying, at the end of the hanger, the component, if it is a non-wash, the garment will get completed there itself at the end of the line. That's it. Right? So it's a very, very efficient system which we are now doing, and tremendous results. Good. So now let us go to the next small section. This is the most important section in this particular seminar. So are we ready to learn about the biggest poison which is present in every company? Now we have completed the 7 waste. Out of these 7 waste, there is one biggest poison which is present in all the companies. What is that biggest poison? We call it as the mother of all the wastes. Yeah. let us revisit this inventory. Let us go back to this inventory. Inventory typically present as three stages: raw material stage, work in progress, and finished goods. Now let us look at the raw materials and FG, finished goods. In most of the cases, the industry determines the stock. Now, what kind of industry I am operating, that industry will determine the stock. I will give an example. For example, there is raw material stock. Let us take that. I have worked with the mango pulping companies, the companies which crush the mangoes and take the pulp and they sell it to Coca-Cola or Pepsi, right? These companies, the mangoes are available only for a few months in a season, in a year, right? Only they are available only in April, May, June, let us say. 3 months only it is available. So these companies, they don't have a choice but to buy the mangoes in bulk and they will store in their warehouse. Only with that mangoes, they will be able to run the plant. They will run the plant during the season time, that is 3 months, and another 1 or 2 months they will be able to run because they have some stock in the warehouses. So they don't have a choice. They have to buy a lot of mangoes and store it. Similarly, if you look at companies which are in steel industry, aluminium, copper, all these metal-based industries, where the global prices, right, the global commodity markets, that determines the prices. Now, if you look at the steel prices are going through the roof. Yeah? So many companies, they would have bought a lot of steel and stored it. If you are from the steel industry, I don't know. You can answer this. Companies have they might buy a lot of steel and they might have stocked them because the prices are going up now. Right? So the industry determines the raw material stock. Similarly, finished goods also, the industry will determine the stock because the customer side, they always have a seasonality. If you look at now, most of the companies are now focusing on the upcoming festival season, because in India, this upcoming festival season is one of the biggest season for any product you take. Right from it starts from August 15, Independence Day. Then you have Vinayaka Chaturthi, then Krishna Jayanti, Saraswati Puja, the Puja holidays, then Diwali, and it goes up to Christmas and New Year. So the last 3 months of the year, there's a big festival season happening in India, and this is the yearly trend. All the companies, they will give a lot of offers. They will try to maximize their sales during this period. So companies like they will gear up for this festival season. So they will try to fill their entire sales pipeline, their warehouses, with finished goods. During the peak season, they will try to sell off this. Air conditioners, for example, the maximum sales happens during the summer season. So before the summer, during the winter itself, December, January, February itself, they will produce to the maximum, stock the entire, they'll fill the entire sales pipeline, have the warehouses filled with materials, and they will try to sell it during the peak season. Right? So every industry has a peak season. Footwear industry, for example, there are 2 seasons. One is the June first week, right? All the footwear companies, because I have worked with Paragon, VKC, etc., their peak season, 2 seasons are there. First peak will happen in June first week during the school opening week. That's when people buy a lot of footwear, right? And the next one, peak season, happens during the Puja holidays. So they will have maximum a stock for meeting the sales, right? So this is how the industry operates. But let us come to the WIP. What is the point of having a lot of work in progress? These are all not finished goods, so they are not ready to be shipped. These are all materials in between the process. What is the point? Why should we have a lot of WIP? WIP can be reduced, no? Right? There is no point in having high WIP. There are so many problems of having high WIP. It takes a lot of space. In your factory, WIP takes a lot of space. It is very difficult to account them. No, it's very, very difficult. No, people I have seen in companies where they fight. The production team will give a particular value to the WIP. Finance team will give a different value, right? So people don't come to terms on what rate I have to take them. Defects and quality issues will arise. No, I keep the material as it is for 1 month or 2 months. After that, all the components become rusted. So you have to use sometimes the rust preventive oil, all those things, right? If it is a chemical based thing, it gets solidified, it becomes expired, right? When it is becoming when it is in WIP stage also. Excess manpower required to monitor them and account them. In one of our clients, when we visited for the first time, there are 2 manpower. Their daily job is to walk through the plant, take stock of all the items, and enter into the system. They're called as inventory controllers. Their job is to daily monitor this Excel sheet. That's it, right? So excess manpower is required, and there is a risk of product obsolescence. What does it mean? If there is a sudden design change in the product, the entire WIP will get wasted. So there is a risk, and too much of confusions in the workplace. If you are a shop floor manager or engineer, you will relate to this, right? There are so much of materials, there will be always a confusion in the workplace. You plan for something, people take some other material and they do it. No, I am planning for, let us say, size 40, but product got mixed up. Size 38 is also present along with 40. So that at the end there is a lot of confusion, rework. So there is a lot of firefighting happens. There is a lack of control if you have lot of WIP. So these are all the problems of having high WIP. So you will all want to reduce the WIP, but you won't do it also, right? You won't reduce the WIP also. Why? Because WIP hides all the problems in the company. All the problems, all the major issues in the company, you can hide them through WIP. That's why as a shop floor manager or an engineer, you don't want to reduce the WIP also. You know that WIP has a lot of problems, but you don't want to reduce. Why? Because it shows when you reduce the WIP, all the inefficiencies will come out. For example, let us take setup time. If your setup time is 5 hours, what you will do? You will have WIP for more than 5 hours, because no, if I don't have WIP, what will happen? And if that particular machine takes 5 hours for setup time, what will happen? The entire line will stop for 5 hours. Everybody will panic. People will call you, what happened? All the line is stopped. Why? What happened? Right? So what you do? Because to avoid this problem to come out, you have WIP for 5 hours, and then now you are you are expressing your intelligence that yes, this because I have this high setup time, I am also having high WIP, so that I make sure that the line does not stop. So I have done a good job because I didn't allow the line to stop, right? So what did you do? You have this WIP and you use that to hide the inefficiency. What is that inefficiency? That inefficiency is high setup time. Are we clear? This happens in all the shop floor. Wherever you see the WIP is there, which means it is used for hiding all the inefficiencies. High setup times, you can easily hide. Poor quality of processes. Imagine there is a particular process which keeps on producing defects. What will you do? You always maintain some stock, right? What happens? Otherwise, if there is no stock, when there is a lot of defects, the next process will wait. When there is a lot of transportation here and there, what will you do? You cannot do one by one. So you always have a lot of WIP to avoid that. Breakdown of machine. When you have a machine breakdown, a machine which is frequently breaking down, every week it will break down for 1 hour or 2 hours. So what will you do? You have high stock. You have some WIP always. Because what will you do? If I during that when I am attending the breakdown, I don't want to make sure that I don't want that other machines to stop. So I have WIP. So this WIP is used to hide all your inefficiencies. It's like a ship sailing in the sea. There are like big rocks which are at the bottom of the sea, and the water level is the WIP. And when the WIP is high, the ship will easily sail through. Nobody will notice the rocks. When you reduce the WIP, the ship will go and hit each of these rocks. So what happens? There will be a panic. Everybody will be watching the shop floor. What happened? Why the machines are stopped? Why the lines are stopped? And now you don't have a choice, right? You have to do the improvement. But instead of doing the improvements, what our people will do? They will again increase the WIP. They will increase the water level, right? And this is the reason why a lot of these lean initiatives also fail in companies. I have seen many companies, before they called us, they would have tried with many other consultants. Many times they would have tried. The idea is they will all have the WIP and then they will try to implement lean, right? It will not work. Why should I reduce my WIP if I have why should I focus on SMED? Why should I reduce the changeover time? If I have 5 hours of WIP, I don't want to reduce the WIP. I don't want to implement SMED. I have WIP to save me. Only if you reduce the WIP, the problems will come out. And then the separate lean has different tools. So each tool will work on a specific problem, right? But the first thing is reducing the WIP and exposing the problems. Once the problems come out, we have to solve each and every problem through a specific tool. For example, high breakdowns. Use a tool called TPM, Total Preventive Maintenance. That particular tool focuses on keeping the machines in a proper condition so that breakdowns will not happen. Then another problem called high setup time. Use the SMED, quick changeover method, single minute exchange of dice to reduce the changeover. There's a lot of defects, so use POKI or TQM, right, and bring down the defects. So each and every lean tool will work only if you don't have WAP. If you have enough WAP and you are trying to implement TQM, TPM, everything, it will all be in the paper, right? It will be in the notice board, but people will not follow that because there is no necessity for me to follow that. I have WAP to save me. Why should I go and implement TPM? I have 5 hours of stock. I don't want to reduce the stock, so I don't want to improve the machine also. Setup time also I don't want to reduce. Why? Because I have WAP. Why should I go and struggle? Right? Only if you reduce the WAP, all the other lean tools will be sustained because there is no other way. No. Once you reduce the WAP, I don't have a choice. I have to do the setup time in 10 minutes or 5 minutes. I cannot take 5 hours because the entire line will wait. Everybody will ask me. So first thing is reduce the WAP, problems will come out, then solve each and every problem. That's how lean should be done. Right? You cannot have WAP as well as lean. It's either or. Either WAP you can have or you can have lean. Right? So because the WAP is the biggest poison and it is a silent killer, I would say. People may not realize this. They think that okay, when I have a lot of materials, everybody will be working. That's what they think. But everybody will be firefighting. With all this WAP also, we are not able to meet the customer demand. You have Sunday work, you have overtime, quality problems, all those things. No. To solve the problems, first thing is reduce the WAP, use specific tools to address those issues which are coming out. Right? It's like opening a Pandora's box. No, that all the devils will come out, and now you have to solve one by one. Otherwise, the devil will be inside the factory only. It will not go anywhere. It will be there. Right? So this is the impact of this WAP. Are you clear? Are you clear? Can you type yes in the chat box if you are clear? Sankit says digital Kanban between cutting. Yes. All right. Good, super. I can see a lot of yeses. Good. WAP is the biggest poison, right? Don't be very clear. Wherever you are seeing materials in between the processes without having any transformation, that is a problem. And who is also nurturing that problem? The managers, the shop floor people. They don't want to solve it. They want to hide that, right? They want to be smart. They don't want to reduce the WAP. Clear? Good. And how to do it? How will you reduce the WAP? Right? And we are coming to the end. Right? There is one magic pill. It's called as continuous flow production. I'm not going to cover this today because obviously for the lack of time, we are almost 11:50. Yeah. And see, how many of you learned something today? How many of you learned something today? Thanks, Jeffrey. I will answer that. How many of you want to learn something? Okay, was it interesting? How many of you want to learn more? Can you type me in the chat box, please? How many of you want to learn more? I'm just going to type me. Yes. I'm going to introduce a small program. Thanks, Durga. Thank you. See, there is a online program called Manufacturing Leadership Program Level 1. It's a 7-day program. 7 days of structured exercises and review. It happens like this, right? Now I am talking to you live, but the same way I have pre-recorded the course, right? Every day it's like 25 to 30 minutes for 7 days with exercises and review and also a certificate, right? If you are interested in learning about lean manufacturing basics, then Six Sigma basics, then production function. This particular course is called Manufacturing Leadership Program, where I try to cover everything a manufacturing leader should know, right? And this is a small portion from that course. A big course is there. I have just taken it as a small course and trying to give you at a very, very low cost. That's why I'm giving this particular thing.